All right, let's talk about building the ultimate AI trader. We're going to go way beyond the usual hype and buzzwords to see what it really takes to create an intelligent trading system that actually works in the real world. We're going to dive into some seriously cool new frameworks that are changing the entire game.
But before we jump into the solutions, we have to ask this big, nagging question. Why do so many trading algorithms, the ones that look absolutely brilliant on paper, just completely fall apart in live markets? It's a huge frustration for a lot of people, and it turns out it often comes down to this hidden flaw in the data that pretty much dooms them from the start. So, let's uncover it.
So our first stop is identifying this fundamental problem. You know, it's like this silent error that sabotages countless machine learning projects in finance, and a lot of the time the developers don't even know it's there.
Okay, so the culprit has a name. It's called label concurrency. Now, what does that mean? Well, basically, when we're creating our training data from financial history, our labels, buy, sell, hold, they often overlap in time. And this violates a core assumption that machine learning is built on. It's kind of like letting a student study for a test while secretly peeking at the answer key. I mean, sure, they'll ace the practice exam, but they haven't actually learned anything for the real thing.
And this quote just nails it. The problem isn't that our AI models are dumb, it's that we're feeding them garbage data. The real bottleneck is our methodology, not the AI's built-in talent.
So, how do we fix this whole mess? Well, we need to build a smarter AI, right? One that can see the bigger picture and, crucially, remembers what it learns. This brings us to a whole new generation of models that are designed to think a little bit more, like us. First things first, we have to give our AI a memory. New frameworks, like one called FinMem, are creating models with these layered memory systems that sort of mimic how our own brains work. This means the model can do more than just react to the latest price change. It can actually process really complex financial data over time and adapt to new signals, just like an experienced human trader would.
Okay, next up, our AI needs to get the context. There's this other framework called macro HFT. And what it does is combine that memory we just talked about with reinforcement learning, which is basically just a fancy way of saying it learns from trial and error. This lets it analyze macroeconomic data. So now, a high-frequency training bot has that crucial context it needs to make smarter decisions, because it understands the bigger economic forces pushing things around.
And hey, why stop with just one AI? A framework called FinCon actually uses a multi-agent system. Think of it like a team of specialized AIs, all working together. They use this technique called conceptual reinforcement, which really just means they talk to each other to improve their collective decisions and manage risk. It's a whole team of experts, not some lone wolf trying to figure it all out.
So we've got a smarter AI with memory, context, and a whole team of specialists. Awesome. But even the most brilliant AI on the planet is useless if its training data is garbage, which brings us right back to that classic core problem, garbage in, garbage out. Remember our old enemy, label concurrency? That overlapping training data gives the AI a totally biased, way too optimistic view of how the market works. So, before our new, smart AI can learn anything useful, we have to clean up its classroom.
And this is where a really powerful technique called sequential bootstrapping comes into play. It's a much smarter way to sample the training data. What it does is it actively finds and avoids using labels that overlap in time. This makes sure that every single piece of information the AI learns from is unique and totally independent. It's like making sure every single question on that practice test is brand new.
And the difference this makes, it's just night and day. Seriously, the models trained on that old, overlapping data, they consistently fail. But when you use these clean, independent samples you get from sequential bootstrapping, performance and robustness just skyrocket. The big takeaway here? Clean data is everything. It is literally the difference between a gambling machine and an intelligent investor.
All right, so we've designed a smart AI. We've trained it on squeaky clean data. Now for the final piece of the puzzle, communication. How does our AI trader actually talk to the outside world? To the trading platform and to other powerful AI services out there in the cloud? The answer is a surprisingly simple but incredibly powerful tool called JSON. Just think of it as a universal language. It's this super lightweight text-based format that lets completely different systems, like a trading bot built with MQL5 and a massive cloud AI like ChatGPT, understand each other perfectly. So here's how that all works in practice. First, you've got the MQL5 bot on your computer analyzing the market. It then packages up its question into a nice, tidy JSON file and shoots it over to an AI service in the cloud.
That big AI does its thing, gets its insights, and sends them back, you guessed it, also in JSON format. Finally, the bot unpacks the message and executes the trade. It's this beautiful, seamless communication loop.
So why does all this matter? Well, when you combine all these things, the smarter models with memory, the clean data, and that seamless communication, we finally move beyond simple pattern matching. We can create systems that can truly adapt to changing markets, that can execute really complex strategies, and that can tap into the power of huge, large-scale AIs through simple APIs.
And this brings us to one last big question to think about. As these advanced tools get easier and easier to use, pretty much anyone with the right knowledge can build a really powerful AI trader. So, in a future where everyone has an AI, who's the one that really wins? Who actually holds the edge? Something to think about. Thanks for tuning in.